Okay, so what I'd like to talk about now are what are known as factors and primes, or prime numbers. So factors. So one way that we can think about this is, imagine if we had, let's say, we had a group of 20 people. So you have a group of 20 people. How many different ways could you divide this group up? So for example, you could have groups of four. Okay, you could four will go into that. You'd have five groups. You could have you could have five groups of four. You could have four groups of five. So five. You could just have one group of 20 people, or you could have 20 groups of one person in each group. You could have one big group of 20 people. You could have two groups of 10. You couldn't really split it up into groups of three. You can split it up into groups of four, into groups of five, groups of six, not so much, seven, not so much, eight, not so much, nine, 10. You could have two groups of 10. So you could have it in groups, you could have two groups of 10 people. 11, 12, 13, 14, 15, 16, 17, 18, not so much, 19, and then 20. So you could divide it. You could divide this number 20 evenly by the following numbers. Or another way to think about it is that all of these numbers here will divide in evenly into these guys, into 20. So each of these numbers then, each of these numbers here, they can be thought of as factors. Or another way to describe them are divisors. Their factors are divisors of 20. So they will divide in evenly. They'll divide, so they're numbers that will divide in evenly into the main number, which is 20. So what we mean by that is that they will divide in evenly with no remainder. So for example, if we take 20 and you divide it by 1, that's equal to 20. If we take 20 and we divide it by 2, that's equal to 10. Okay, so there's no remainder. If we take 20 and we divide it by 4, that's equal to 5. If we take 20 divided by 5, that's equal to 4. And then if we take 20 divided by 10, that's equal to 2. And then if we take 20 and divide it by 20, it's equal to 1. So that's what we mean by factors. They're numbers that will divide in evenly into 20. So these can be considered factors of 20 or divisors of 20. Now another thing that you might notice as well is that you have these pairs here. So if you look at these guys, so these pairs, so we'll just look at these now in turn. So if we just write these out, so you have 1 multiplied by 20. Okay, so that's that first one here. You have 2 multiplied by 10. You have 4 multiplied by 5. You have 5 multiplied by 4, and you have 10 multiplied by 2, and then you have 20 multiplied by 1. So these here are what are known as they're pairs of factors. Okay, so these are pairs of factors. So you notice that each of these numbers by themselves will divide into 20, and then when you multiply them by each other, it gives you 20. So for example, you have all of these guys here. So 2 and 10 both will divide into 20, and then when you multiply them by each other, you get 20 as well. So these are known as pairs of factors, or factor pairs. Now, one thing that you'll notice as well is that every number, so if you think about the factors, so if we think about the factors of 20, for example, you have 1 and 20. So the number, so every number, so if you take the number 4, for example, so what are the factors of 4? Well, 1 is going to be a factor, 2 is going to be a factor, 3 isn't, and 4 is. So you'll notice that with every number, 1 and the number itself are always going to be factors of 4, and these are also, it's also a factor pair, because if you multiply 1 by 4, that's equal to 4 as well. So again, so these are all factors, but then you also have the factor pair then as well. And the number and itself are always going to be a factor of every number. Now, just one other idea that I want to kind of introduce is this idea of what's known as the highest common factor. Highest common factor, or what's abbreviated as HCF. So the highest common factor. So if we think about, let's say if we take two numbers. For example, we have, let's say 16, the number 16, and then we have the number 24. So these are two numbers. Now, if we think about what are all of the factors of 16. So 1 is a factor of 16, 2 is a factor of 16, 4 is a factor of 16, 5 isn't, 6 is, 6 and 6 is 12, so 6 is a factor, 7 is not a factor, 8 is a factor, 9 is not a factor, 10 isn't, 11, 12, 13, 14, 15, and then 16. So these are all the divisors or factors of, these are they're the factors of the number 16. Okay, just put this out, just doesn't look right. So you have 4. Okay, so these are all the factors of 16. So if we think about the factors of 20 then, 1, 2, 3, 4, we have 6, we have 8, for example, 12, and 24. So these are all factors. So these are all factors of 16, and they're also factors of 20 as well. Now, this idea of the highest common factor. So the highest common factor is so you list out all of the factors for each. So it's between two numbers. So in this case, it's going to be between the number 16 and the number 20. So you list out all the factors like I've done here. So each of these are factors because each of these here are factors of 16 because they'll all divide in evenly into 16. Now, and these are all factors of 24 because they'll all divide in evenly in 24. Now, if we think about like what is the highest common factor, so it's a factor that's common to both of these numbers. So if we think about, if we have a look here, so what's the biggest? So 1 and 1 are common factors between 16 and 24. 2 and 2 are, 4 and 4 are, 6 and 6 are, 8 and 8 are. Now the highest common factor between both of these numbers is this number, is this factor here, which is 8. So this would be known as the highest common factor because it's common between both of these numbers. So it's the highest divisor, or the biggest number that will divide in evenly into both 16 and 24 in this case. So this is this idea of what's known as the highest common factor. That's kind of like what it's talking about. So just a little bit of a recap. So just very quickly, so we have factors, and I'm not going to talk about prime numbers in this example. Well, okay, what I might actually do is I'll just quickly introduce prime numbers. So prime numbers then are, so if we have a look at a couple of different other examples, so let's just have a quick look then at what prime numbers are. Now, if we take the number, for instance, so let's say, so prime factors. So if we think about the numbers, for example, let's say 5 and 7 and 3, for example. Now let's say if I wanted, what are the factors of each of these? So what I would invite you to do is just pause the video and list out what are the factors of these 3 natural numbers. Okay, so if we think about 5, for example, so 1 is going to be a factor and 5 is going to be a factor. There are no other factors for 5. There are no other numbers that are divisors that will divide in evenly into 5. If we take 7, for example, again it's 1 and 7. There's no other numbers that will divide in evenly into 7 or divisors. And then the same with 3, it's 1 and 3. So if we think about these numbers, so these particular numbers here, so 4, 7, and 3, these are what are known as prime numbers. So prime, what that means is that prime numbers only have 2 factors. They only have 2 factors. One and the number. So 1 and the number itself. So what we mean by that, if we take 3 as an example, 1 and 3 are the factors of 3. So there's only 2 numbers, 1 and itself. So therefore, these here are examples of what are called prime numbers. So that's what we mean. So prime numbers, that's what we mean by prime numbers. What we can do then as well, if we take numbers, and I'm just going to rub out some of this here as well. Let me just move over a little bit. Let me expand this canvas a little bit if I can. Okay, so let me see. So what we can do then as well is we can take numbers and we can we can express numbers as products of their prime factors. So what does that mean? So if we have a look back here, so let's have a look at some of these examples here. Well, actually, okay, let's just have a look. Let's look at it like this. So let's say if we have the number 12, for example. So what are some of the factors of 12? What are some of the prime factors, numbers that are prime numbers but are also factors of 12? So if we think about, for example, we have a factor pair of 12. Okay, one of the factor pairs of 12 is 4 multiplied by 3. So we see here that 3 is a prime number. Okay, so the only factors of 3 are 1 in itself. Now if we take 4, for example, we can break this down further into 2 prime numbers. So 4 is also, the factors of 4 are 2 by 2. So 2 multiplied by 2. So what we could actually write this then. So 12 is equal to 2 multiplied by 2 multiplied by 3. Now this here, what this is an example of. So these are all factors of 12. They're all prime numbers. But this is a way that we can express a number so we can express a number as a product of prime factors. So what we're doing is we're taking this number 12 and we're expressing it as a product. So product means multiplied by as a product of its prime factors, and that's what we have here. So if we look at each of these numbers, so 2, 2, and 3, these are all prime numbers because the only factors that they have are the number itself and 1, for example. So this is a way where we can express a number as a product of its prime factors. So, okay, so that's what we mean. So that's just a quick introduction to factors and primes. So factors, again, just as a reminder, are numbers that will divide in evenly into another number, or divisors. So if we take 20, these here are examples of the factors of 20. Now, and as you see here, we see that they all divide in evenly into 20. Now, we can also write them as pairs of factors. So these are two numbers that when multiplied by each other will give you the number, but each of the numbers that are multiplied by each other are also factors of the main number as well. In this case, the number is 20. We can have this, what's called the highest common factor. So if we take two numbers and we list out all the factors for each number, and it's the highest factor for each of the factors for each of the numbers, but it's the highest one, it's the highest number. So as an example, we have the number 16 and the number 24. These are all the factors for 16. These are all the factors for 24. 8 is a common factor to both, and it's also the highest common factor. There's no other common factor between both of these, so these are what are known as the highest common factor. Prime numbers then they're numbers that have factors, but the only factors they have are 1 and itself. So as an example, 5 is a prime number. It has the factor 1 and 5 and no other factors. And these are rules for factors. And then you have this idea of you can express numbers as a product of their prime factors. So product means multiplied by. So if we take the number 12, for example, we can express this as a product of its prime factors. So it will be 2 multiplied by 2 multiplied by 3, that gives you 12. These are all prime numbers, and the product of them, when you multiply them by each other, is 12. So that's what we mean by that. Okay, so hopefully that makes sense. Thank you.